Okay, so let's look at another example of finding the derivative of a log function where the base is not e. All right. Um, so in this example, we're differentiating a function, this function that I'm using LG to represent, and that's my notation for log base 2. Which is another important base for logs. So we want to find the derivative of log base 2 of square root of x over x plus 5. Now, because this expression inside the log is kind of complicated, it's really going to benefit us here to take a little time and before we start actually computing the derivative, and use properties of logs to rewrite this function. So log base 2, the so-called LG function or binary logarithm function, obeys the same properties as the natural log function does. So that means that we can expand this expression by taking the difference of two binary logs. So log base 2 of square root of x over x plus 5, that's going to be the same as log base 2 of square root of x minus log base 2 of x plus 5. And now working from this expression, I think that's going to make it easier for us to calculate the derivative. Actually, let me take this one more step in my simplification, because using log properties, because square root of x, of course, we can rewrite that as x to the 1/2 power, and then using another of our properties for logarithms, we can bring this exponent in front as a coefficient, right? So we've done that several times through the course, right? So we can really write log base 2 of square root of x as 1/2 times log base 2 of x. All right, finally now, I think I'm ready to actually compute the. Finally now, I think I'm ready to actually compute the derivative. Okay, so there's my function expression written in a slightly different way, and now let's calculate y prime. All right, so of course we know how to compute the derivatives of expressions involving natural logs, right? And as we saw earlier, just a slight variation on that rule for natural logarithms, for finding derivatives of natural logarithms, will allow us to find derivatives of logarithmic expressions of other bases, right, like base 2. Okay, here's the rule. I recopied it from earlier in the notes. All right, so if we want to find the derivative of log base b, where b is some base other than e, right, of an expression, well, again, we take the derivative of the expression and we divide that by the expression. But since this is a log of a base other than e, we also have to multiply into the denominator here the natural log, natural log of the given base. So very similar to the derivative rule for natural logs, right, except you've got this one extra factor in the denominator, and that's the natural log of whatever base you're using. All right, so to calculate the derivative of this function, to calculate y prime, or of course we could write that as dy over dx, right? Let's take this term by term, and first let's start with by finding the derivative of log base 2 of x. Of course, we have this coefficient of 1/2 here, so that's going to stay. And now, according to this rule, right, what is the derivative of log base 2 of x? Well, you take the derivative of x, right? That's the expression you're taking the log of, right? Of course, that's just going to be 1. And then that's divided by the expression itself, so it'll be divided by x. And then remember, we have to multiply in here also the natural log of our base, which in this case the base is 2. So we'll multiply in the natural log of 2. So there's the derivative of the first term. What about for the second term? Well, we just follow the same rule, right? So we're going to take the derivative of x plus 5, which is still 1. We're going to divide that by the expression itself, which is x plus 5, of course. And then, just like in the previous term, we have to multiply by the natural log of the base, and of course this is base 2, so we'll multiply by the natural log of 2. Alright, let's rewrite this slightly. So I have, for this first term, 1 over 2 times the natural log of 2 times x. I'm going to put 2 times the natural log of 2 in parentheses here just to make sure that we understand that we're not taking the natural log of x. All of this is multiplied by x. And then minus natural log of 2 times x plus 5. That's y prime.